Fernando has a question about the DH key distribution. He thinks the sets A and B should have primes less than P. Is that true?
Yeah, so in Diffie-Hellman, we have the exponents A and B that are picked. They don't have to be related to P other than if P is very small, there's no point picking really large values for A and B. If P is really big, it's silly to pick small values of A. So the exponents are usually recommended to be at least 256 bits, and that's because there's an attack where the work is related to the square root of the size of the exponent rather than to the actual exponent. So if you want 128 bits of security, you need a 256-bit value. You need to select A as a random value up to 256 bits. And that means if P is too small, well, your attacker will go after P instead of focusing on the attack on A. But there's no particular relationship between the size of A and the size of P.
He also has another question about Diffie-Hellman. He wonders why, in practice, it's less accepted than RSA.
So this is a good question, and they're both actually widely used in practice. RSA is more widely used and more talked about. They do different things. So it's not a question of one being thought of as being more secure than the other. And the security of both depends on quite similar problems. Diffie-Hellman depending on the discrete log problem, RSA depending on factoring. There's no reason to believe one of those is easier or harder than the other. And the property that Diffie-Hellman gives you is just this key agreement property. RSA can do more things like digital signatures and encrypting messages. So that's a more versatile cipher. You can do more things with RSA. All you can do with Diffie-Hellman is agree on a key. But there are ciphers built on top of the same ideas as Diffie-Hellman that can provide the same properties as RSA.